Able TA Lesson 12A homework question number 8. Melissa flipped her lucky coin 11 times and got 7 heads. Melissa used these numbers to estimate the probability of getting a head with her lucky coin. What is the estimated probability of Melissa flipping a head with her lucky coin? So we want to find the probability of getting a head over the total number of times. So we're going to take the heads, which is 7, divided by the total, which is 11, and that'll give us the probability of getting ahead with her lucky coin. So rounding this out to 3 decimal places, we have point, let's see, this 3 will not make the 6 a 3. I guess I should make this a little bigger because we're, there we go. So this 3 will not increase this 6, so out 3 decimal places is just 636. The next one is find the margin of error for Melissa's estimated probability above. To find margin of error, or what I like to call as MOE, also known as MO, that is the formula 1 divided by the square root of n, n being the total. And if I wanted to find my sample statistic, that's just x divided by n, which is what we did for this one. X being the characteristic that we're interested in, and n is still the total number. So Mo is a squirt. I know it sounds silly, but if you can give yourself a mnemonic to help you remember that, then it'll speed you up. So 1 divided by squirt, or square root. So we have 1 divided by, to get square root in Excel, we type in squirt or square root, and then we type in the total number. She flipped it 11 times, so we have 11, close parenthesis, or it's okay if you don't close it on here because it was pretty Excel knew to close that one. Okay, find the margin of error in Melissa's estimated probability above. So round this out 3 decimal places, gives us 0.30, and this 5 will round the 1 up to a 2. So we've rounded it out 3 decimal places. Next, create a confidence interval for the chance of flipping ahead with Melissa's lucky coin. So we're going to take our sample here, the probability, and then we add our margin of error because it gives us our wiggle room for our confidence interval. And I'm going to go left to right. So we're going to go low to high. And because I have these here, I'm just going to calculate them on Excel. So we're going to do this, and we want the low, so we're going to subtract our margin of error for the low, and for the high part of the interval we're going to equals this and add our margin of error, and that gives us our wiggle room for our 95% confidence interval, which is rounded out to 3 decimal places, 0.33, and that 8 rounds the 4 up to a 5, and then the high number goes let's see, that 8 rounds up to 7, so we get 0.938. All right, next, can Melissa conclude that the probability of flipping ahead with her lucky coin is actually different from 0.5? So in here, flipping a coin repeatedly should give a probability of about half and half, or 50-50. So can we conclude that her lucky coin really is lucky? Considering that 0.5 does fall within this confidence interval, so they overlap, I'm not going to say that it's really that different from 0.5. So I'm going to say no. The possibility, so it would be illogical to think that her lucky coin is actually lucky and different from 0.5 based on her sample of data. And we get our green check marks to verify and move to the next one.